Okay, so now we need more derivatives in order to proceed. So we need the derivatives of the trigonometric functions, so the trig functions. All right, so we'd seen two of these already. We saw the main ones. Derivative of sine x is cosine x, and the derivative of cosine x is minus sine x. So we already saw that in a previous section. But what we want to do, so let me separate those. So what we want to do is look at the other trig functions, the four other trig functions, and see what their derivatives are. Again, I'm going to show you that with the knowledge of derivatives of sine and cosine, we could derive what each one is. But these are ones that we want to commit to memory because we want to be able to use them quickly and easily in the midst of bigger problems. Okay, so I'll also show you how I tend to remember these. Okay, so let's go to the derivative of tan x. All right, the derivative of tan x is secant squared x, while the derivative of cotan x is minus cosecant squared x. Okay, so the way I remember this is the derivative of tan is secant squared. So that's the one I really remember. And then when I'm asked the derivative of cotan, I say, oh, that's like the opposite of tan. So the derivative of cotan is cosecant squared, but with a minus. All right. Similarly, the derivative of secant x is secant x tan x, while the derivative of cosecant x is minus cosecant x cotan x. So again, I say to myself, all right, derivative of secant is secant tan. Derivative of cosecant is cosecant cotan with a minus. All right, so I tend to remember these two and then figure out these two as being the, complementary ones to those with a minus sign. Now, I did say it is possible to derive these. So let's see if we know the sine and cosine derivatives, how we could actually figure this out. So the derivative of secant x, let's say we wanted to figure that out. Well, secant is 1 over cosine x. Okay, but now we do have a quotient rule to take care of a situation like that. So again, I'm going to look at essentially the top and the bottom. Okay, so I'm going to look at the derivative of the top is the derivative 1 times the bottom as it is, cosine x, minus the top as it is, 1 times the derivative of cosine x, all over cosine x squared. Well, the derivative of 1 is 0, so this whole thing, it knocks out the cosine there, and I get minus, and the derivative of cosine x, 1 times I have 1 times the derivative of cosine x, so I get minus sine x, so sine x, and then that flips around the sine, and cosine x squared. Okay, so in the numerator I just get sine x. And in the denominator I'm actually going to write it as cosine x times cosine x. So I have sine x over cosine squared x. That doesn't look like what I said before. Now I'll show you that it does. So I could take this first cosine x, separate it out as just 1 over cosine x times sine x over cosine x. And what I see, we see that we get 1 over cosine x, which is secant x, times sine over cosine x, which is tan x. So I do see that I get the derivative of secant x to be secant x tan x. Now, I don't want to have to do that every time, but at least it's there if I need to do it. I can do it that way, but it's best if I am just able to see secant x and know its derivative is secant x tan x. There's not going to be a huge number that we're going to have to know routinely like this, but it is very helpful to be able to do that just from memory. So let's practice these in some examples here. All right, find dy dx for each function. So find the derivative. Okay, so y is 3 secant x minus 2 tan x. All right, so dy dx. So now these derivatives we know fit into the rules from before. So I have this constant multiple 3, which is just going to stick around, and then I take the derivative of secant x. We just saw that that's secant x tan x minus the constant multiple 2 stays around, and then the derivative of tan x is secant squared x. Okay, and so that's my derivative. That might be okay for here. Likely in the future, if I want to work with this, I might want to factor out a secant x. So look at this as secant x has 3 tan x minus 2 secant x. But that's not really a must. That's just something we should be flexible with if we need to later on to simplify or to put it in the form we want. So this would have been fine here. Okay, how about 1 over sine x plus 4 cotan x? All right, so here, if I want to do the derivative, I actually should stop for a second and think about, oh, maybe I should rewrite this. Okay, I could perfectly fine go ahead and do a quotient rule on each piece of this, but I might want to avoid that because I actually know that 1 over sine x is cosecant x plus 4, and 1 over cotan x is just tan x. So I have a much simpler derivative to do there than it looked. So now I can just do the derivative of cosecant x, which again, I think derivative secant is secant tan. Derivative of cosecant is cosecant x cotan x with a minus in front. All right. Plus, now the derivative of 4 tan x, I have a constant multiplier 4. Derivative of tan x, secant squared x. And that's good. Okay, we'll go back and circle the previous one. All right. So now we're going to mix it up a little bit in that I have to be conscious of the fact that, one, I might be in different variables, and I also have to be on the lookout for different situations. So now we're going to do it in r and theta, dr d theta as the derivative. All right. I could write r prime if I wanted to. All right. So when I get to this first one, I have theta cosine theta. Now don't be looking at the trig function yet. First, we have to identify that what we're looking at is a product. We're doing the derivative with respect to theta, and we have two functions of theta right there. So I have to do that as a product first. Then within that, we'll get to the derivative of the trig functions. Okay, so now I'm going to take the derivative. So I'm going to take some of these derivatives in one step. So the derivative of the first, so derivative of theta is 1 with respect to theta, times cosine theta as it is, plus the theta as it is, times the derivative of cosine theta, which would be minus sine theta. Okay, so that's all right there, the derivative from this product. Then I would add on the derivative of cotan theta. All right, derivative of tan is secant squared. Derivative of cotan is cosecant squared with a negative. All right, so I'm going to actually flip this around from positive to negative, and it's cosecant squared. Okay, so now I will clean this up a bit. Cosine theta minus theta sine theta minus cosecant squared theta. Oops. Not x. I should have thetas in here, not x. I'm getting overly used to x's here. So let me change those to theta. Okay, and there we go. Okay, this one looks like a bit of a mess here. So r equals secant theta cosecant theta. So first thing I recognize again is I have a product of two functions. So if I'm going to do dr d theta here, I have to use a product rule. So the derivative of the first, so the derivative of secant theta is secant theta tan theta times cosecant theta, second thing as it is, plus the first piece as it is, secant theta, times the derivative of cosecant theta. All right, so secant was secant tan, cosecant is cosecant cotan with a minus. So I'm going to change this now to a minus, and I said I have, I don't like that minus, and I have cosecant theta cotan theta. Now this looks like quite a mess, and I mean that is the derivative, but one thing you might consider with trig functions is if it is this type of a mess, it might actually simplify a little, and I should go back to my sines and cosines and see if I can work this out better. So that's 1 over cosine theta times sine theta over cosine theta times 1 over sine theta minus 1 over cosine theta, theta, times 1 over sine theta times cosine theta over sine theta. And what I notice is that in the first one here, sine thetas can cancel. In the second one, cosine thetas can cancel. And I actually get 1 over cosine squared here, which is secant squared theta, minus, and over in the second term, I get sine squared in the bottom, so 1 over sine squared is cosecant squared theta. So that's just a bit of a nicer look to the answer, and that could be helpful going forward. All right, so those are just some trig function derivatives.